Start recording. The recording started. The octave is on, and everybody's ready. Both of you. All right. In follow, we had last week some example and the entry stuff. You guys remember how to define the for loop? So you got to start with the for loop with the instruction of for, and then then a variable you got to define, initialized variable, right? And you can define how long the loop is going to run, right? And there's several ways we did in last class. Remember, you use the length function. So if you're dealing with a matrix, right, and you know the number of elements can be explored by length function, so you can define it at the beginning of the for loop by doing like for I equal 1 colon that length of that matrix, right? So that is the way of defining how many times the for loop is going to run. Okay. So after that, obviously, while you are running the loop, like computing some operation inside the for loop, you would like to write some code. Those codes should belong to whatever mathematical operation or some other operation that you'd like to do, right? So this is an example, like you are doing a multiplication or addition or subtraction, whatever, right? With a complex algebraic equation, right? And you have some variable that was defined before as 0 before the for loop start. So you keep adding every time the for loop run, you keep adding the result of that computation or the algebraic equation that I was saying. Keep adding that value every time the for loop is running. Okay, so that is one way we have learned in last class, right? And then you end the loop, and then you would like to display the result by using what are the functions that we usually use to display the function to display the result. Fprintf, fprintf, and display itself, right? Now there's a problem with the display function, right? You can't display the variable value just the way we used to do in fprintf. Remember, in fprintf you have the options like percentage of or pointer you can create by percentage or either f or s or whatever, right? By the variable, and we've seen the syntax, we know everything, right? So these are the quick summary of what we have done so far, right? We had so many examples. Now what we'll be doing today then? We'll be doing some more examples, right? And one biggest one that we'll be doing today is kind of the difficult one as well, is the projectile motion. We have learned the projectile motion, right, in plotting. Remember when in 1 week in plotting class we did do that, right? But here in this class we'll be using the for loop to explore, okay, the different location value x and y at different times, right? Okay. Okay, so that's the intro. Any questions so far? The lecture is in record. If you don't understand anything, or if you are not able to copy, type anything, you have the access later to do it. Okay. All right. Let me get my notes at the same time. So I'd like to start with this one. Yep, perfect. So let me start with the title. So my title for today's class is, this is for loop. Okay, week. For loop part 2 and part 3. Okay, because two of the lectures that we're going to do it today. Okay, and then the title descriptions. So other things we can do with for loops means the examples, right? What are the things that we can do? Obviously you'd like to start with the main code with what? Anybody remember what do you use? Like CLC, clear, close all, right? All those things. Don't want to write the explanation of those things again, and let's start with the real thing. Okay, actual for loop. I'd like to start with example 1 for today's class. And remember, if you have 2% sign, that's actually referring to a section in MATLAB. In Octave, they don't recognize it as a section, but the same code, when you're going to run it in MATLAB, you're going to see when you have a 2%, it will going to colored by one section. Okay, so that's the beauty of it. So 2% is important. 2% sign. All right. So the example 1 would be user input in a loop. Like it's still a very rudimentary thing. I would say, like, the homework that you'd be doing much advanced, okay, but it's asking you, why don't you create a loop, and every time the loop will gonna run, you're gonna ask the user to give a value so you can create a matrix. Does it make sense? So that's what we're doing. Any question? All right, let's start. Okay, so you would like to create a loop. Let me explain a little bit more. So you'd like to create a loop. Create a loop that prompts a user to input values to create a matrix. Okay, what does it mean? Like, you have seen before, creating a matrix, you do it manually or from Excel, right? Like you kind of give all the elements value one by one. Okay, however, what if you'd like to ask the user every time to give the value when the program is running? So that's what you're doing. So you'd like to create the number of elements of the matrix, like n equal to 5. So that will going to clearly shows how many number of iteration at the same times for the loops needs to done, right? So that's the number of elements, number of iteration needs to be done. So then you'd like to write the for loop as for j equal 1 colon n, and then you'd like to write that matrix element, where this is where you may get trip off. So please pay attention. When you're trying to excuse me, define a matrix element, okay, matrix element usually referred by the indices number in the parentheses. You remember that? Say like X is a matrix, right? It has, say, like 5 elements. So first element is X parenthesis 1, second element is X parenthesis 2, right? So the same thing we're doing here inside the for loop, right? But instead of X 1 2 3 4 or whatever, since we don't know, like the J is a variable, right, which you're gonna, every time the for loop will gonna run, change the value. So initially it is like J equal to 1, then J equal to 2. So in other words, initially the value would be X1, then X2, X3, X4. That way you are creating the matrix. Got it? All right, what you're doing here then, you are asking the user to give an input. What input? So, and the input, you are asking, please enter a number, right? And then you are putting a space. And then let me put some explanation. So reminder, this xj is building a matrix, okay, because we are putting the value in the jth position. Let me explain it a little bit more. Not the matrix type, this came automatically, okay, from here maybe. Okay, so the reasoning is because we are putting the value in the jth position. You know what is jth position? Like xj is here, is referring to jth position. It's a fancy of saying, like, you're creating the element of the matrix x1, x2, x3, x4 this way up to 5. All right, so then you'd like to end this. That's pretty much it. That's how you're defining the matrix. Okay, so once you're done ending, and then you save it, right? Obviously I'd like to save it to some location here maybe. So this is week 10, lecture 1. See how time fast, time is running so fast. Would be almost at the end of the semester. You remember, right? I did mention this exam, the final exam, I'm gonna give it as a take home. Remember that, right? You guys wanna do any project? It's so many homeworks, so many so many things, right? This is 3% class, and I know you, all of you, in person. So I mean, I don't know if Renzo is gonna show up ever, but other than that, 3 of you I know, and I know all of you are very good and what you're doing, right? Jason, you understand everything now, right? Without any issue. So I am kind of confident with all of you. Like Ben is like missing something. When you're gonna come, I'll make sure you're gonna catch up. So I'm feeling confident with the take-home exam. Okay. So the take-home would be like, I'm gonna assign it on week 14. Okay, and it would be due on the exam week. Okay, not necessarily. So there is no way like you can submit it in week 14. You can maybe, but technically you shouldn't. So like you'd be engaged in exam week. Okay, you're supposed to engage in exam week. Makes sense? Usually I don't do take home for this class. Okay, I'm doing it like 3% of what I've been doing. You do it at your own pace. Okay, how about that? So that could be a breather for you, I guess. Okay, moving on. So week 10, lecture 1. So I'm gonna save it this way here. All right. So then fprintf. What I'll be doing with fprintf? Fprintf. I'm gonna create. This is the interesting thing that that's the interesting thing that I'll be doing. I'm gonna create some new line. Remember, /n is a new line. One /n is one new line. Another /n is another new line. In other words, what will happen after the program is gonna run? The cursor will gonna go up to the up to like 4. How many times? I have 3 times, right? Three lines down. Okay. All right. So or 2 times, doesn't matter. I just want to create a space. All right, so the next example. So now that we created the matrix, right, we'd like to display the matrix. It makes sense? So you can display the whole matrix by just displaying fprintf and x, and that way percentage of f or whatever. But the other way could be, why don't you create a matrix, why don't you create a for loop that will gonna create each element. Does it make sense? Why don't you create a for loop that is gonna display each element every time the for loop is gonna run, one of the element is gonna get run. Okay, just so you understand what I'm saying. So now that you have the matrix with 5 elements, we'd like to display each of the elements separately, right? Separately. So that's what we'll be doing in another matrix, another for loop. Sorry. Am I talking too fast? You guys understand what I'm saying? Issues? Should I talk slow a little? Good. Good. As a small part, it's a small class. That's why I'm doing this way. I mean, I usually don't like to talk this way. Okay. All right.
Question though. So
yeah.
On the fprintf.
Yeah.
With the 2 /n. What is that?
That 1 /n do like next line. So basically, I shouldn't do it here actually. Actually, I should be doing it after the display because nothing got displayed yet. Okay. So we'll be doing it. So remember, I was just talking about another fprintf to display the result, right? Remember that? So let me write it quickly. So another for loop to display the results, right? So for that one, okay. So for that one, I'll be using say like k. I'm doing a little shortcut here, okay, and instead of n, I'll be using this length. Remember the length x is the matrix, okay, and then I'll be using this fprintf, right? Now that I have the thing defined already, so I'll be using fprintf, and then inside I'll be using value, then percentage of 0.0f. Don't type of. O will gonna not run it, and percentage of 0.0f and percent of 2f. Okay, so what is doing, the first one will gonna first percentage of 0.0f will gonna display the index number of a, and the second one will gonna display the result of the element. Okay, so then after that you'd like to put 1 /n, and I'll explain all these things, don't worry. So then xk. Okay, so if you're gonna do that, then it will gonna get displayed. Okay, and then I wanna put some notes here. So this is my example 2. So in my example 2, so I have used a for loop to print results to the command window. Okay, and then this fprintf you want to put it here. Okay, and just before this, if you'd like to put another fprintf just to display like what is happening now, so you want to put like another fprintf, and you'd like to put inside that fprintf Say like 1 /n, 1 /n. Just to answer your question, anytime you see a /n, that means the cursor will gonna move to one line down, one line down, one line down. Does it make sense? /n means new line, n means new line. So as if like you're saying the cursor to move to the new line, new line, new line. Otherwise, what would have happened? You would have this line showed up, and then another line create just immediately after that. After that, whatever is done, means like say you have a text, immediately after that text in the same line something will gonna start showing up. So there won't be any new line. Everything will gonna show up one after another. Does it make sense? So that's why this /n is so important. So as an example, in the second for loop, you see I have a /n just after percentage of 0.2f. What does it mean? So every time the for loop is gonna run, it will gonna get displayed, right? Ethan, you understand what I'm saying, right? It will gonna get displayed, and the next time when the for loop is gonna run, a new line needs to display in the second line, not in the same line. Does it make sense? So that's why you have the /n. So important. All right. Okay. So another thing that I would like to do, let's put a title like 2 /n after the first one. The values of the matrix are shown below. Now what I'm doing here, right? I'm just simply n /n. I'm just simply putting a title, right? What is happening? Does it make sense? It's a title. All right. So then what? After this, I'd like to. I'm gonna give you some time to catch up. I have to talk a little bit more here though. I'd like to put a note here though. So the note should be this fprintf has two inputs. What are those? The k to tell. Okay, let me go a little bit deep, right? K to tell what? Which value it is. Okay, the k is like the, remember the matrix element number. I'm sorry, it didn't come to my mind. Matrix element number, right? So that's the k, and then and xk, which is actually the value itself, right? You had it input to grab the kth value from the x matrix. Now here's one thing to notice. You see here in the second matrix and the first matrix, we have one had k and another had j, right? So if you are defining those variables like k or j, make sure you are consistent inside the matrix. It makes sense? So if you are defining like k for the second for loop, you'd like to keep k with all the elements or all the math or all the algebraic equation or whatever you have. It should go with k, not the j, not the I. The same thing goes for the first for loop. Everything should be j. So that's another important point. Okay. Anything else? Now this k and j, does it really matter this variable needs to be this way? No, it could be any variable. You can name it Jason, you can name it Ethan, right? Still it will gonna work. Okay. All right. Any question with those? So at this point, you definitely want to run it and see if it runs. So you're gonna run it, and I have an issue. I'm sorry, I put a capital C before CLC. Okay, so I'm gonna run it again. Okay, now it's talking. It says, okay, please enter a number. What number? Number for a matrix, right? I don't know. Maybe I'd like to put 2, then 3, then 6, then 50, then 90. Now here's one thing that you're seeing. Every time I'm entering the value, the x value get displayed, right? You may not want to show it. You may want to show the final result, like the value of 1, value of 2, value of 3, that way, the elements, right? So to do that, you'd like to make it a little fancy, right? You may want to put a semicolon. It should work this way. So let me run it again. Okay, so 2, yep, it is running now. So you may want to put a semicolon. Does it make sense? You see now, it looks much more professional, right, Ethan? So after putting the semicolon, when you're done, let me know. I'm gonna move on, and also ask me any question if you have any so far.
Go back to the code.
Yes. What I did, I just put a semicolon here. That's the highlighted thing. Let me know, Jason, when you're done.
Yeah,
Ethan, you're done? Let me know you are done when you're done, Ethan. Done? Alright, example number 3. A new thing, a beginning of a new thing. Both of you understand about the /n, right? What is the purpose of the /n? Alright, so example number 3. So it is producing a series. Still we are dealing with a small example, a for loop. Now you might be seeing it in your homework, right, already, and you might be having some issues as well, like with the homework, with the series, right? So maybe you can take a little bit time for that to submit, okay? Not necessarily by today, okay? If you'd like to submit, you can submit on Wednesday, but I'm gonna upload a new homework today, okay? That is due by Monday next week, okay? Just want to give you a heads up because of the series thing. But after you're done with this homework, the second homework won't be that bad. All right, so producing a series for a for loop, it's a very important one. Okay, what you're doing, lots of explanation is to be done in terms of the series, what kind of series that we are trying to deal with here. All right, so let me start from here. Okay, some text. So use a for loop to create a vector containing the first 10 elements in the series. What are those first 10 elements in the series? That is what? -1, -4, -9, 16, 25, sorry, -25. Series requires a little bit of thinking, and this should go, so this 3 dot means it should go up to 100, okay? So to define that series, you got to know how many elements that there, okay? Or how many times that you got to do the iterations. Now that's where the for loop and while loop differentiate, okay? In for loop, you don't know how many times when you're going to run it, how many times that it needs to run to get the final value to 100. Make sense? In while loop, however, you can define how many times it can run, not like many times, rather you can define by condition that the loop will gonna end when the final value is 100 or less. Does it make sense? So that's what the for loop and while loop, the basic difference is. For loop, you don't know, you got to arbitrarily choose like number of times it is going to run, and you don't know whether after that many runs it will going to give you like 100 or more, okay, but you are just kind of going on luck, okay? But in that case, obviously you're going to run the while loop, right? So you can put a condition. Any question? Understand, Ethan? All right, so that's the question description, and obviously we're seeing here, so that's another catch here. Obviously we're seeing here the series, all the elements, not all the elements, like some of the elements value that they started with, like, you know, it should start with -1, then -4, then -9, you know, then 16, then -25 again. So like it doesn't follow in pattern, right? It does, so it seems like that way. So I mean, either you need to know what is the series for these numbers, okay, or you gotta explore it by yourself, right? By just doing like, you know, all those maths, like, okay, if you have a minus, how many times the minus is there, then how many, so those sort of things you gotta figure it out, okay? All right, let me give you the solution anyway, then you'll be understanding it right away, how to deal with that. So you wanna define the number of iterations we want. Okay, so again, I did explain what does it mean, why I'm saying number of iteration you got to define first. So you have, like, say like the 10 number of iteration, and then you have like 4 I equal 1 colon capital N, and then AI equal, that's the element, right, of that series. You want to define minus 1 to the power, actually I did a mistake, there should be, yep, now there's this minus 4 was wrong, take out this minus before the 4. So okay, minus 1 to the power I. What does it mean? To the power I. What does it mean? Okay, Jason, if you're gonna have a power of minus 1 to 2, that means minus 1 square. That means minus 1 multiplied minus 1, which is what? Plus 1. It makes sense? So if it's odd number, say like if you have a power of 3, say like minus 1 to the power 3, that means minus 1 multiplied minus 1 multiplied minus 1, that means you have minus 1. So you get the pattern. If it's the odd number, then it is negative. If it's an even number, then it is positive, like the power I'm talking, right? So the I value will gonna get changed. Ultimately it will run 10 times, because 10 times iterations. Every time the for loop will gonna run, I value will gonna change, and you're gonna have either minus or plus, minus or plus, minus or plus, because the number goes with odd and even. So 1, 2, 3, 4, 5, 6. You understand? So that takes care of this minus thing for sure, right? Without any question. All right, if that takes care of this minus thing, you have any other clue for the other thing? So you have, like, you see, if you multiply 2 multiplied 2, that is 4, right? Then you have 3 multiplied 3 is what? 9. 4 multiplied 4 is what? You get the idea? 5 multiplied 5, 25. 10 multiplied 10, 100. Got it? So that's the way you gotta do. Okay, so the second one would be multiplication, and you wanna do the multiplication of what? I. So I, because you define I, right? Square. Does it make sense? So like I, when the I value is 2, then it is 2 square. When the I value is 3, then it is 3 square. When the I value is 4, then it's 4 square. When the I value is 5, then it's 5 square. Make sense? You see the series? Okay, it now started to make sense now. Okay, so then you'd like to, put a semicolon and then end this for loop, right? And you can actually display the whole thing by doing the fprintf as well, if you'd like. Or you can simply at the end of this simply type A, then it will gonna display the A. So you can do fprintf as well, I guess. So in fprintf, okay, example 3 series results. Say, elements are, you can put a percentage of you can do it so many ways. You can do individual one, you can do the whole thing as by simply typing A. But if I want to do the individual one, I don't have it in the notes, but I'm just creating something. So percentage of 0.2f, let me do it this way. Okay, and then /n A element. I'm doing it a little differently. Okay, this is, I don't have it in my notes, so I'm just creating something. Element number percentage of 0.0f, right, is, and then I can do what, like comma and then I, and then AI. This should do, right? If you're gonna run it, okay. All right, you see, these are the series element. It makes sense. You can also do it this way, just simply typing A, right? After the fprintf, you can simply show this matrix by simply typing A. You can do another fprintf and then just simply show this here. Let me see if it works. So example, this is A. Elements. Okay. Only the last element is shown. That's the problem. Okay. So I'm going to take it out. We're going to display it that way. And if we need the value of the A, just simply type A. Okay. Anyway, it was good so far. Jason, you're good. You don't get it?
It's not showing up the number of the element.
It's not. So like you may need to put 0, not O. Did you put 0 or O? Not working? No working? I have 2 more examples, right? Today's class is a little bit longer, even though it started 20 minutes late. But I have 2 more examples. One is a projector example, another is the hamster row. Okay, another series. So those could be helpful to you for the project. Sorry, for the homework.
I got it.
There's another example. it was running before though, right?
Yeah.
And then suddenly it's just showing all these things. Even the first one. So non-conformant it's so weird. I don't know. Don't ask me why. I just all thing I changed for your case is move, change keep small and lowercase letter and to capital letter N. Anyway, so two more examples, then we'd be done today, right? One very interesting one that we'd be doing now, hamster one. Okay, that example. Let's start with that. So this is example number. Example number 4. So you may want to type this. This is a very interesting problem. So you would like to calculate the family growth for hamster. You know how drastically the number of hamster grows. What kills hamster? Huh? Raccoon? Does raccoon has anything to do with hamster? You know, one time I had one raccoon. I live in woods, right? I had one time in one raccoon, and then it got exploded with 7 more babies. All right, and then all those raccoons. I mean, raccoons is a dangerous thing. You know that, right? They have the rabies disease or whatever. I mean, not always all of them. So they were sitting under the what this thing called on my backyard, right? And then every time I opened my backyard, they were all coming, and it was like a scary situation. I have a small kid, so I had to buy a trap, and every night I used to get one raccoon by putting a marshmallow, and then every night I got one, and then I had to throw them out, after driving like so long in Canton somewhere in woods. So that way I had to go 7 times. you know, it was a crazy experience. Anybody had bad raccoon experience?
Not bad raccoon. My father always tells the story of how he killed his brother's hamster because he was playing on the front lawn. Because he stepped off the porch onto the front lawn. And so dad stepped down
Hamster?
on the hamster and squished it.
Wow. Hamster was not that bad, but raccoon is so scary. You know that raccoon could be dangerous. Anyway, let me move on with the problem descriptions, right? So calculating the family growth for the hamster. I used to have a hamster for my kid. He wanted to buy it. I brought it, and then he never fed him, so I have to feed him all the time. I was so tired. I give it away to anyway. So what do you want to do? So you want to start. So like you'd like to start a business of selling hamster, right? So you want to calculate how many hamsters you can have after 5 generations, right? Assume we start with just one female hamster. Okay, assume every baby hamster produces 10 new babies for the next generation. Oh, that's a lot. Alright, so how are we gonna do that? So 5 generations, every, excuse me, we have to deal with 5 generation of hamster. Every hamster produces 10 babies. Okay, how many hamster you are expecting? A lot, right? They're gonna eat everything that you own. Alright, so you're doing a business, that's why you're growing them. Okay, so let's start by defining the variable which is g equal to 5. So like g is the generation, you probably got it already, and then the comment would be obviously number of generations. Alright, so then you'd like to define total hamster population by using pop, means population pop, right? So the first element for pop matrix, you want to define pop is the population matrix, you can say this way, and you'd like to define it. Okay, it is 1, and then define this thing by defining our matrix that holds the total hamster population for each iterations. Okay, and then each generation, I'm sorry. Okay, so then let's start with the for loop. So for I, and again it doesn't matter whatever you are defining variable name, I, j, k, l, m, n, u, p, and whatever. So then this pop, remember the pop matrix element, you can define it this I plus 1, as if like you keep adding the value of the population every time the generation runs, right? And the 5 generation of production happening, right? For the 5 generation of the production, you would like to do it this way, like 10 multiplied the population of the previous generation, which is I. So you see, the important point here to understand, I have a note here though, but the important point here to understand is like, you see, this I variable get increased up to 5 generation, starting from 1 to 5, right? And then what the calculation is doing for each of the hamsters, since 10 of them created, so you're multiplying 10 with each of these population element, matrix element, right? So population matrix element is for first generation is 1, right? So what happened in first generation, you have just 1 hamster, right? So it will gonna create 1 multiplied 10 means 10 hamster, right? So then second generation you have now 10 hamster. What will happen now? So when the for loop is gonna run for the second generation, now your I value is now 2, right? So you have population 2, remember population 2 was what? 10. You defined it in the first run of the for loop. So now population 2 means 10 multiplied 10, and that would be assigned in population 3, right? But the third generation, so before the third generation began, because each hamster create 10 of them, so there are 10 in second generation, so like there would be total 100 hamsters, right? Does it make sense? So now the for loop is going to run for third time, and in third time you already had 100 multiplied 10, so thousands, 1000, in other words you have 1000 hamster in population 3, end of population 3, or at the beginning of population 4. Does it make sense? So that's the way you are calculating it. Somebody's texting me, I guess. Okay, very important. Alright, so then you'd like to put a note here, whatever I explained here. So we have 10 times as many hamsters in each subsequent oh generation. Okay, you'd like to display this result as well, right? Fprintf. So fprintf, so the number of hamster after percentage of 0 f generations. You know, anytime you have a integer which doesn't have a fraction, you'd like to put percentage of 0. Does it make sense? So like number of generations, there is no integer, right? There is not a half generations, 2.5 generation. There is like 1, 2, or 3, 4, 5, 6 generation. So that's why you have this percentage of 0 f generations, right? Is then again percentage of 0 f exclamation. Now this is like exclamatory, right? Because see that many numbers. So okay, again hamster can be like half hamster, 2.5 hamster, because hamster is one hamster. Okay, so this would be integer again, and then /n. Okay, what it is gonna do, move the cursor to the next line, and then you'd be doing like these two variable, like one is the g, other one is the pop n. Now there's the thing, instead of writing pop 5, you'd like to write pop and. Okay, and is the and element of matrix pop. Does it make sense? This is also very tricky, new thing that you learned probably today. Okay, probably you didn't do it before. So pop and is showing you how many of the total matrix at the end of 5 generation. And means like the fifth in this case, right? So and is generic. What if you have not like 5 generation you are talking 50 generation, 2 generation, 20 generation, 100 generation, number could be wild, anything. So then and would be getting the last element of that matrix pop. You understand? Everybody? All right, so if you understand everything, we are actually done with this section. We just have one more thing to do. And this should be helpful to deal with the homework problem, the second and third one. And that's why I'm extending the homework deadline to Wednesday, okay? So you have this number. All right, so the total number of hamster, that's the last line. Take a look here, 100,000. After 5 generations, you'll have 100,000 from one hamster. Obviously, that hamster needs to be breeded somehow. But if that's the case, then these are the scenario. You'll be doing very good in business because you are doing a business here, right? Selling hamster. I still remember I had to spend more than $10, around somewhere $20 for the one hamster. It was long ago, 8 or 9 years ago. And then that hamster died when I was traveling, and my son was saying, like, my son is almost your age now, 17 years. So my son was saying, getting another one. So, and neither of the time he ever fed, like probably barely 1 or 2 days. I had to deal with that. And then I give it away when he loses attraction. Anyway, you gotta do it for kids. Everyone understand? So far you guys good? You guys want a break for the final thing? Before the final thing? Will they charge up and everything? Okay. No break, nothing. Okay, perfect. I don't want to give any break either. I want to finish it and then relax as well. This class on Monday is a little bit challenging. I mean, but I've done this class, you know how many times I did? Like at least 7 to 8 times. Sometimes in 1 year I had to do it twice. So, I mean, I'm here almost 10 years, right? But I've been starting doing this. I know each and every line almost like by heart. That's why it doesn't bother me that much. Anyway, everybody's good? Okay, should move on. Okay, so what is that? Okay. Actually, I have few more examples, not only one, but I'd like to do just one of them. In the second class, I'm going to do more, okay? Let me do the difficult one, which is the projectile motion. You guys remember the projectile motion? You had the physics lab. I know, Ethan, you do. Jason, you had the physics lab, but you do, right? The projectile motion.
No, I haven't next semester.
Next semester. But you have an idea about the projectile motion already. I did explain before, right?
Yeah.
If something is flying, it does have x and y location, right? If it's in 2D, if you have the equations x and y, like you can either explore it in matrix chapter. We did it, right? You can either explore it by using the matrix, or you can use it like even the matrix, but inside the for loop, right? Does it make sense? So either way it will work. We're gonna use for loop this time. Okay. So let's start. So that would be our example number 5, and would be doing projectile motion with predefined matrices. Okay. So define the constants ay equal minus 9.81. You know what is ay? Remember that? What is ay? It's the gravity, right? Gravitational acceleration acting downward, that's the negative. If you are assuming the y is positive direction, upward, and then with the unit of what? What is the unit? Meter per second square, right? And that's the acceleration due to gravity in y direction, right? And negative is because it's negative y direction. You'd like to define the theta. So define the givens. What are the givens? The theta equal 15 percentage of degree, an angle for throwing. Then VO equal 180 meter per second. That's the initial velocity. Initial velocity. Okay, and initial XO means X location, not XP. Sorry, XO equal 0. Okay, don't get confused with 0 and O. Make sure you typed it correctly. And the unit is the location. I'm saying in x direction would be meter, right? So this is your initial x location, right? And then I'm gonna do I'm cheating, which is like copy and paste, and I'll just simply change it to y. So this is initial y location, which is also 0 by the way. And then I'm gonna define the T matrix, which we have done it, I don't know, more than 10 times already maybe, with the interval of 0.1, and this T is the time matrix, obviously, if you remember. The unit of s or second, right? And this would be your time matrix. Okay, and then I would like to initialize, right, x and y result matrices. So what are them? The matrix where, okay, sorry, matrix. Jason, you remember the matrices is the plural number of matrix? Ethan, you know that, right? Alright, so the matrices where x and y positions will be stored when they are calculated, when they're calculated in the loop. Okay, that's what the parenthesis ends. So you see what you're doing, you are defining the x and y result matrix, right, here by doing this x equal n a n. Now you guys remember n, a capital N means not a number. I don't know if I used it before. but that one needs to be multiplied with a ones matrix. Now you guys remember the ones matrix, right? So ones matrix is all the elements are 1, right? And then you can define it this way: 1 comma length. So that's the beauty of it, length, and then t. Remember, so the t is number of elements in the length function. We're going to explore number of elements in the t matrix, right? Now you did define t matrix like 0 to with the interval of 0.1 to 10, right? You know how many is there, but what if you are dealing with a very complex number, right? Say like instead of 10 it's like 19, right? And instead of interval of 0.1, instead of interval of 0.1 it is like 0.19, right? So you don't know then the number of elements, right? So that's why the length function is so important, okay? And what you are doing here, you are predefining the x and y matrix. What are they? X and y matrix are the location for the projectile, right? Why you are doing it? You could ask all these questions, right? Why you are doing it? Why you are predefining it? What's the benefit of predefining? To help run the program faster. So computationally efficient. That's the fancy of saying that. You heard about this term, computationally efficient? Yeah, okay, computational. Very good. Computations we're gonna do faster. Bottom line, right? So if you're gonna predefine, now how? I know I'm saying like why we're doing it, like everything, but how? I mean, you may not know. Like the way it happens, like when program runs, right? It does store things in a RAM. You know what is RAM? Okay, so RAM is the temporary space where the things get stored, right? There is the hard drive where permanently you are storing something, right? So if you have it defined, you are locating it on the RAM, like the location of this individual element of that X matrix, at the same thing for the Y matrix. If you're defining the matrix this way before you are running it, okay? Otherwise, if you didn't define it, you are running it in for loop. Every time the for loop is going to run, it is going to wandering from the beginning and it is going to find a location, right? As if like it is like, you know what I'm saying? As if like you have to go wild, like find a location. Does it make sense? If I think you understand what I'm saying, right? So that is so important. Defining the matrix, predefine the matrix, so you're going to run it faster. At some point, I might have a program, I remember, which is going to show you how fast it is going to do, right? Now, it's all not just word, okay? It does have like, physical evidence. I'm going to show it to you at some point. Now, let's move on. Like everything that I said so far is just to motivate you why you are going through this trouble, right? Just predefining the matrix. So this should be a practice for you as well. So then I'm going to do a little cheating. I mean, obviously, I'm going to put a semicolon here, and then I'm going to do like copy this thing, right? Maybe you can do the same, just changing it to y, right? And then just simply changing it to y. That's it, okay? And then what we'll be doing, you see here, take a look. We are initializing the x and y result matrix, right? The matrix where x and y position will be stored when they are calculated in the loop. You see what I just said? It's the summary is there. Okay, so the next line, I would be determining the initial x and y velocities based on the theta and v0. V0 is the initial velocity, right? You remember, Jason, I did explain before, like if the v or velocity has an angle, right, Ethan? So I have two components. One is the x component, another is the y component, right? How do I find it? So if this is v0 or initial velocity, if I know the theta, so v0 cos theta would be the x component, right? v0 sin theta would be the y component of this direction. Does it make sense? So x and y component, okay? This is the fundamental geometry stuff. That's what I'll be doing next. So let me write it. So write the loop to use, next line I'm doing. So you are determining the initial x and y velocities based on theta and v0. Okay, so what you're doing, so like vx equal vo. So remember, not the v0, vo, right? And you got to make sure it's capital V, because that's how you define the capital initial velocities. So vo multiplied by cos d. That's another important thing to remember. Remember, you had this cos and cos d. Cos d is for theta in degree, right? So that's the function you're using, theta. So cos d theta, and then I'd be putting a note here which is the unit of meter per second because it's velocity, and then you can say this is your initial velocity in x direction, right? I don't know what is happening today. I'm doing too much of typo. Direction. Okay, initial velocity in x direction. Okay, and then I'm gonna do a little bit of cheating here, just like before. I'm gonna copy it and paste it for the y. So this would be vy, and this would be sine d, right? And this would be in y direction. Okay. So then, I mean, we are almost at the main point here, now running the loop itself, right? So for I equal, now again this I could be anything, j, k, l, m, n, o, p, whatever you prefer, 1 colon length. Now anytime you have a function, you remember, you never when I start with a capital letter, function always goes with a small letter, right? So length, and then what is this length? Length of t, right? The time matrix. For each of the time element, the matrix, the for loop must needs to run to find the position of x and y. So that's our goal, right? Yes, you understand? Each of the time element, we are exploring the x and y equation to find the location of x and y, right? So that's how you're doing it this way. All right, let me put a note here. So this will repeat for however many values are in matrix T. Okay, and then you'd be writing this way, calculate x and y positions based on t. What do? X I equal xo. That's the equation, simply equation, right? So xo, make sure you put xo, not x0. I was doing the mistake. Plus this vy, right? Vy multiplied by this ti. Now you have been doing it quite some time already, right? Inside the matrix, you got to put the element like as a parenthesis I, parenthesis k. We've been doing it, right, Jason, for so many times. So this shouldn't be that difficult to understand. And then you have a unit of meter, obviously. And what you're trying to find, you're trying to find the x position, right? And then obviously you'd like to find the y position as well. I'm gonna do a little cheating, but that will not gonna help me too much, but still whatever can help, whatever can do. All right, so you have this y0 instead of x0, you have yi, right? The second one would be as it is, but you'll have this 0.5, okay, multiplied by ay multiplied by ti squared. Now why didn't you put a dot before the power sign here? Anybody can answer me? As an individual element we are talking, we are not dealing with the whole T matrix, right? If you would have done with the whole T matrix here without the for loop, then we would have put like the dot, just the way we have done it before. Remember, Jason, in matrix chapter we had to put the dot. We are not doing it here. Individual element we are exploring. Anyway, so if you understand, okay, make sure this is Vx. I had a typo here. Let me highlight that. So I had a typo here. It should be Vx. Got it? So correct it. And then I'd like to put some notes here, more notes, right, about the equation. So as a reminder, right? What is the reminder? What is you're trying to remind? So these are the equations we used for the plane problem in homework number 4. Remember the plane, somebody was falling down. Yeah, so what is this equation? Xi, right, equal xo plus Vx multiplied t, right? And do a little cheating here for yi, and this is, you must want to put a percentage sign, right? because this is notes for your reference later. So yi, this is y, this is y, right, plus half of, right, half multiplied ay multiplied t square. Remember that, right, those two equations. And obviously then you're done with everything. So you're going to end this loop, right, and this for loop. Make sure you put the and after every for loop, else loop, otherwise it will not going to run. So and for loop. If you are dealing with cascade loop, remember cascade, one loop inside another loop inside another loop, this complex problem. You would like to put like notes probably after every and, like this one is for, this one is for and that way you won't be having mistake. Sometimes you have for loop inside another for loop inside another for loop. So that could be like for loop 1, for loop 2, for loop 3, whatever. But this and you would like to put in notes. And finally, I mean, remember, I did talk about it during metrics, right? When you had like this kind of thing explored, like x and y, so many values, right? I mean, hardly is even comprehensible. It's comprehensible for you to seeing the data. It is almost impossible, right? So you'd like to plot, right? Obviously, almost all the time when you have multiple data, like a lot of data. So you'd like to plot the solution, right? And you'd like to do it this way. Say like plot. Okay, you have this x comma y, and then it's up to you like how you'd like to display the plot. How beautiful. Like if you'd like to put like O as a symbol and K is a black color, right? You want to do it this way. And there is the other option, the line type, line width, all those things you learn, right? Let me just change one of these as a reminder. So line width, right? And then you want to put a comma and then 2. No, don't put a quote for 2, number 2. Remember that. And then you'd like to do x level, very important, right? At least very minimum you'd like to do x level on y level. In x level you'd like to put, okay, this is in x direction distance, and in y level you'd like to put, and now we had like only x and y value. Now in matrix chapter we've seen, right, what did we see? We had the values in with respect to time, right? Both values x and y. And you can do the same here by doing the subplot as well. Okay, that can be done as well. So the y distance in y level is in y meter, and I'd like to put a title here, okay, and the title should be path of projectile, right? And then oh man, enter a number. Don't worry, I'm gonna come back to that just shortly. Just one second. Let me see if it's running. Yeah, it is running, so I'm good. The code is good. And that's it. We had, I guess, like if things go like this smoothly, maybe we can cut in one class, right? For for loop, we gotta do the second class, okay? But for while loop, maybe out of 4 class, we can do 3 class. If it goes smoothly, we'll see. All right. This is ready for you. All right, I don't see it. It's ready. Jason, you have any question?
Nope, I'm good.
The homework deadline, I put it like verbally, so you know when to submit. I haven't uploaded new one though. I'm not going to change today, okay? And again, Wednesday is due for 9, okay? And next week Monday is 4, okay? All right, guys, I'll see you. Have a good day. Jason, you got to catch up with SOIT 116, okay?
Yeah.
You want to do a project by yourself, or you want me to define something generalized?
I'll do it by myself.
Okay, perfect. What you are thinking for project? I have 2 students that explore 2 different things. Maybe that will gonna give you some idea. Okay, one student is doing a restaurant he'd like to open in future. Okay, so he wants to. I mean, I give him some suggestions. He wants to open a restaurant. So I say like, okay, why don't you go to Parkros? You have been in Poste Parkros before? They renovated it completely, right? Got it renovated. Okay, So positive part what we're going to go. They have like some conference room. They have the kitchen obviously. They have the bathrooms, right? So and they have the open space for so many chairs and seats, right? So like when what are you gonna do? Say like you wanna. I mean I'm just saying that guy. Okay, I'm just giving you some idea. So what you're gonna do? Like you're gonna do two drawings. One is the floor plan itself, which has like everything that what we're doing. Like, we're missing classes, but the block thing, what we're doing, with the floor plans, we're putting all these stuffs, right? The kitchen stuff and everything, okay, toilet stuff. You can do it like by doing the floor plan. That won't take that much time. But the challenge would be to do the exact one. Like sometimes in real life, you may purchase some property and you may want to renovate it. So that's when like you may want to go in person. You may want to measure everything, and you may want to draft it from scratch. Okay, that is like existing one. Otherwise, the other one would be like you don't have anything left dark, or you have built something from dark. Then you have more liberty, right? But the second option, first option that I was saying, that maybe you plan to explore. That's what I said to that guy. I also said to that guy, okay, that could be one aspect of it. Like you had the floor plan with all the kitchen equipment, so all the blocks and everything, fancy, perfect. But you don't get that much time to do it, right? Based on the knowledge that you have. Now, you can do one thing, like if you have some of the blocks that needs to be created, that we're learning now how to create blocks, right? So if you have some of the blocks that needs to be created, that could be one interesting thing that you can do on the block, right? You can create some of the blocks, and you can actually make this deal like really sweet if you can add like what is that? Mechanical electrical block. If we can add that, that could be adding like so much value to it. That means it's a complete drawing, right? And MEP, mechanical electrical and plumbing, right? You can obviously deal with the sprinkler system, you can deal with the pumping system, you can deal with the electrical deployment system. This is extensive, but this is project, like your interest, right? You'd like to explore. Not necessarily I'm teaching any of this thing in class, right? MEP, there's something you can explore by yourself, right? Now you have the basics, don't worry about it. Because we are almost done. So chapter 10, there's like only the dimensioning and plotting, and it's almost nothing, right? So you guys are actually done. You now know all the tools, right? How to modify stuff, how to create. Like, it could be complicated, but you know how to do it, right? So yeah, that's what I was telling one student. Other students want to do a floor plan of a house. So I mean, just start from the beginning, like that could be one. So these are two ideas two students are doing. Like I was talking with Taylor also, just encouraging to do something. I have something as like common to it. So not everyone is common to it. So that's what common is stuff. But I'd say like what's good. Okay, what like, talk with me. It makes sense. Okay?
So with the project, I could do like, right now my house layout that I'm building.
Anything. Yeah. Definitely you should do that. And as I'm saying, I will have something for everyone, but that's for like those who doesn't want to go extra. Okay? I feel like you understand and you're interested in this, so you should be on your choice, right? Understand? Yeah, you should be beginning it right away. This is week 10, right? It takes a lot of time to do the project, right? You should be doing it from this week or next week.
So what exactly is the project? We're just making a floor plan for.
Yeah, you can just do a drawing file, you can get a plot printout or something. I mean, to do a plot printout. Okay? Because we'll be learning the plotting, and you know how to print out, right? Also the dimension and everything in the floor plan. That's what you're gonna learn. But before that, up to this point, you know how to create the plot, how to insert the plot from the library, how to create from the sketch, right? You know how to do the floor plan, right? You have all the basics already, and it's straightforward. If you got what you did at the hospital, you do the same thing I was showing you. Yeah, I was showing you how to do the windows first, right? Also, and then the book does have everything as well. You make it all. Right? You have all the tools now. After chapter 10, you now have everything to draw it. Now to make it fancier, like plotting all the other stuff, you need a little bit of time. You don't need it now. You can start it, right? You don't have to wait for that, right? Understand? The project, I'm saying. All right.
Okay.
Okay.
See you later.
See ya.